In this video, we'll discuss solving linear equations. Now, an equation is a statement that has two expressions that are set equal to one another. We're often trying to determine the solution or solutions that will make that statement true when a value is substituted in for the unknown or variables. Linear equations specifically have 0, 1, or an infinite number of solutions. For example, with 3 plus x equals 9, we're trying to ask ourselves, what value can we plug in for x that will make this equation true? And we know that the solution here would be that x would need to be 6, because 3 plus 6 is 9, therefore 9 would equal 9. There is no other solution that we could plug in that will make this a true equation. Therefore, the only solution is x equals 6. For example, if I substituted in 4 for x, that would not make a true equation, because 3 plus 4 is 7, not 9. So when we're solving linear equations, we want to make sure that as we simplify from one step to the next, our equations maintaining balance. In other words, the equations are equivalent from one simplification to the next. As you do this, here are some general guidelines that can be helpful. First thing, if there's fractions, it may be easiest to multiply all the terms in the equation by the least common denominator. Then we can start to simplify each expression on the left-hand side and right-hand side individually, if it's necessary. Then we can actually start dealing with simplifying the overall equation. Whatever we do to one side, we must do to the other. We start with addition and subtraction, and we do that to both sides with the same values. Then we multiply or divide both sides by the same values. At that point, we should have the final solution. To verify that it is an accurate solution, we should always substitute back in to make sure that the solution does make the equation equal. So let's say we're trying to solve 6m plus 13 equals 1. There are no fractions in this equation, so I can move to step 2. Honestly, I can't simplify either expression anymore, so now we can move to step 3, which is looking at addition and subtraction on both sides of the equation. Here, since I have plus 13, I want to subtract 13 from both sides so that I can work on trying to get the m by itself. Now I'll subtract 13 minus 13, that should equal 0. And then 1 minus 13 will give me negative 12. So my new equation is 6m equals negative 12. That is an equivalent equation to the 6m plus 13 equals 1. Now, all I have left is the 6 with being multiplied by the m. So I'm going to divide both sides by 6. This will leave me with 1m equals negative 2. So to verify that this is an accurate solution, I'm going to substitute in the negative 2. So 6 times negative 2 is 12. Negative 12 plus 13 is 1. My left side equals my right side. Therefore, it is the correct solution. Now what happens then if we get a little more complex? Here we do have a fraction. It is with a denominator of 3. So since there's only one fraction, we'll say that is our LCD. That means we're going to multiply every single part of this equation by 3. By doing this, my 3 will simplify the other 3 so they become 1, leave me just with my numerator on the left-hand side. Now I'm going to simplify the rest of my expressions on the left and on the right. If I look at my right-hand side, I want to distribute the 3 to both terms. This means 3 times 4 will become 12h, and 3 times 15 will become 45. Now I am down to where I can add and subtract to simplify my equation. The first thing I'm going to do is I'm going to get my h's on the same side. I like to keep a positive variable as I'm solving equations, so I'm going to subtract the 5h from both sides. 5h minus 5h will go to 0, and then 12h minus 5h will give me 7h. Now, I'll look and say, well, what's still here? I have this minus 45 with the h, so I'm going to add 45 to both sides. So 45 minus 45 plus 45 will go to 0. 4 plus 45 will give me 49. Now I'm down to one last step. This is 7 times h, So I'm going to divide both sides by 7. So 7 divided by 7 will give me 1h. And then 49 divided by 7 is 7. My last thing then is to substitute 7 in for h and verify that my equation is equal and that I've solved this correctly. So 5 times 7 plus 4 divided by 3, and 4 times 7 minus 15. And I'm just going to simplify a little bit at a time. So this is 35 plus 4, and this becomes 28. And then this is 39, and then 28 minus 15 is 13. Last thing to do is double check my division here. I get 13 equals 13. Therefore, I know that h equals 7. It was an accurate solution. All right, now let's look at a more complex problem. In this case, I have variables in the denominator. I can still follow my same steps to solve this because it's only one variable that I'm dealing with. So the first thing I want to look at is that fraction and say, let's look at the denominator and create an LCD. Now, it can be kind of hard to do this. So the first thing I do is I factor these down to their simplest terms so I can see what do I need to multiply everything by to make the denominators go away and only have to deal with everything as if it's all integers. So in this case, I have this 2x plus 8 and say, can I simplify that? Yes. I can factor that to 2 times x plus 4. And the right-hand fraction is still x plus 4. So I can say, well, what's the least common denominator? What's the 2 times x plus 4? I need both of those parts. So I can look at the LCD as being 2 times the quantity x plus 4, or I can look at it as being 2x plus 8, so I can simplify a little bit easier with each of these equations. So for my left expression, I'm going to multiply it by the 2x plus 8. The 3, I'm going to multiply by 2x plus 8. And the last one, I'm going to multiply by 2 the quantity x plus 4, because it allows for a little bit easier simplification. That is an equivalent expression, so either can be worked with no issue. The nice thing here is that when I simplify, 2x plus 8 will simplify with 2x plus 8 to 1, and the x plus 4 will simplify with this x plus 4 to 1. So it allows for easier simplification. Now I can go through and simplify the rest of each of those expressions. The left-hand side is perfectly simplified. There's nothing else I can do. But on the right-hand side, I can distribute, and I can do the 2 times 8. So I distribute the 3 to both terms. This will give me 6x plus 24, and then the 2 times 8 gives me 16. Now I'm going to add my two constants together so that I'm left with 9x plus 16 equals 6x plus 40. Now I can start working on balancing the equations and simplifying. So I start with my addition and subtraction. In this case, I'm going to subtract the 6x from both sides so that I can keep my variable positive. So 9 minus 6 will give me 3x, and 6x minus 6x will give me 0x. So my new equation is 3x plus 16 equals 40. Now I'm going to subtract that 16 from both sides so I can get x by itself. So 16 minus 16 will go to 0, and 40 minus 16 will give me 24. All I have left is 3 times x, so I divide both sides by 3. So 3 divided by 3 is 1, and 24 divided by 3 is 8. So I have a solution of x equals 8. I want to verify that that is accurate, so I'm now going to substitute 8 in to my equation. 9 times 8 plus 16, 2 times 8 plus 8, and then 8 divided by 8 plus 4. So 9 times 8 is 72, 2 times 8 is 16, and 8 plus 4 is 12. I keep simplifying. 72 plus 16 is 88. 16 plus 8 is 24, and then 3 plus 8 twelfths is 3 and 8 twelfths. So the question is this improper fraction equal to this mixed number? So I'm going to take my improper fraction and simplify it and see what happens. So if I take 88 24ths and simplify it, I can divide them both by 2. That's 44 twelfths. And 12 goes into 44 3 times with a remainder of 8. Therefore, it is an accurate solution. It's a little bit more complex than the other equations, but it still works.